Hi everyone, I'm Tianzhi Jing from Zhejiang University, and I'm a PhD candidate. And it's my honor to introduce our work AutoSpark and supporting automobile appearance designs in ideation with Kansei engineering and generative AI. And product appearances can attract consumers to make their purchasing decisions if it is satisfied consumers' emotional needs. But creating designs satisfying to these needs, it poses a challenge for designers. It's not only demands a precise understanding of the object emotional needs like elegant card and sport card, and also needs the ability to translate them into concrete and appreciate design elements. And Kansei engineering is a technology that has been used to build the models to link them. But here, the keywords that represent the emotional needs are called as the Kansei words like elegant, sport, and luxury. But Kansei engineering only considers the limited existing designs, draw inspirations only from these cases that may cause design fixation to the designers. And to address this, generative AI has been like the text-to-image models and LLM has been introduced to assist designers, but most current research only considers the realm of artistic paintings like illustrations and graphic designs, and there's little discussions on the industrial product designs. And industrial product design aims to generate innovative solutions that can adhere to emotional needs and the predetermined physical forms of the product. And then it also requires more the display in my computer is different from the screen. Yeah.
Yes, shall we try to unplug it? Yes, let's try to. Oh, it's in Chinese.
Yeah.
Can you click on that again? Oh, can you maybe go to? Can you select mirror, or do you need the? Oh, I'm sorry, that's not a good idea. You need your pause, right? Okay. Can you try to go to like in English it says Referentenansehen. What does it mean? Like great. Yeah, perfect.
Thank you.
Good.
Sorry. And we continued. And the product appearances that aims to generate innovative solutions that adhere to our consumer emotional needs and from the limited physical forms. So it also recommends a transparent generation purpose.
Okay. Okay, can you go to the next slide already? And then
let
restart?
me try.
Yeah, I think it works now.
Okay, thank you.
Can you go to the next slide? Yeah.
Yeah,
okay,
okay, thank you. So in order to address challenges we gain, and also to gain insights into how these models are currently enhancing the workflow of our automobile appearance designs, and also understand the limitations designers faced in their design process. And we conducted formative studies. And according to our participants, there are 4 common steps that followed when creating designs. It is analyzing emotional needs and translate them into the design elements, and sketch schemes, and find tons of details. And our observations of human AI co-creations also revealed 3 main challenges. And firstly, because Kansei words carry inherent subjectivities, and the same Kansei words can lead to wired design directions, and the model's interpretations of these Kansei words may diverge from the designer's expectations. It also leading to some unsatisfied results. And secondly, it's very hard for designers to translate their design intentions about design elements into many text prompts, especially when it involved explaining many shape designs or many uncommon color designs. And thirdly, the lack of transparency and interpretabilities in the generation process also make designers be caught in adjusting the prompt and losing insight into their initial ideas for iteration. So, informed by our formative study, we outlined the 4 design goals for our system, and we developed our AutoSpark. And it is an interactive system that provides creativity support for automobile appearance designers in the early conceptual stage. And it mainly facilitates the creation process through 2 main stages. It is exploration and comparison. And in the exploration stage, AutoSpark helps designers to first dive in on the input Kansei words and clarify the directions through the overlay of multiple Kansei words. And then it recommends some design schemas, and it also aids designers in extracting textual design features from the schemas. And based on the designer's selection, the system will generate some prompts with the LLM and utilize a text-to-image models to create inspiration to the designers. And in the comparison stage, it also offers some image-to-image and text-to-image comparisons to explore and refine the generative designs. And here is our demo. Firstly, designers start from the exploration page and input and Kansei word. AutoSpark will break down the input Kansei words by generating several related Kansei words. And designers can choose the pace they made that made their expectations, and ask the system to recommend some existing designs or images. And then they can browse these images, select that provoking creative insights, and ask the system to extract design features within it. And it's for textual descriptions. And these textual descriptions detail the designs of 8 mainly components of the automobile across the 3 different design dimensions like shape, color, and texture. And the components of the automobile will be the body shape, air intakes, and many other things. And the designers can select the design features they are interested in and add it into the feature extraction part as a candidate part for the prompt generation. And after adding all these candidate design features, and designers can edit and select the features again and request the system to generate a text prompt. And then they can refine it and generate automobile images based on the refined text prompt. And designers can also revisit results and select their preferred one and add it to the tree structure. We call this design thinking map. And all this relevant information through the creation process, like Kansei words and the design features and design images, are all managed and documented in this tree structure. It is design thinking map. And then they can switch to the comparison page. And AutoSpark can arrange all these design schemes on a canvas based on their visual similarities, and they can also switch between the different comparison modes, like general modes and 3 specific modes for comparing their shape, their color, and their texture. And designers can also investigate how specific Kansei words or specific keywords in the prompt can influence the generated images with our text-image comparison. First, they can input the keywords, and AutoSpark will display a heat map that indicates the extent of the Kansei word's influences on the specific areas. And the designers can then revisit the exploration page and further refine their prompts and or iterate their designs. And to support Kansei word diversity and translations, we also developed the KE agent. And first, we collect comments on existing vehicle models from internet, which provided by consumers and many automotive critics, and also the images of the automobile appearance designs. And then we extract the Kansei words from the comments and construct a semantic network. Here is how we construct it. And first, each node in the network represents a Kansei word. And then, when two words co-occur in a comment of the same vehicle models, we deem that they are related and connected them with an edge labeled with these vehicle model names. And then, the numbers of related vehicle models will define the weight of the edge between the two nodes. So we can get the more frequently the two Kansei words occur across different vehicle models, the stronger relationship between them. And when a designer inputs a Kansei word, a system will first employ the KE agent, retrieve the top 10 Kansei words most strongly related to the input one, and then provide this as a knowledge for GPT-4 to reasoning. And when translating them to concrete designs, and KE agent will identify the 3 vehicle models across the edge between 3 models that appears most frequently across the engines and return their design images. And here is our evaluation result. It can be seen that the alignment score between the target Kansei words and its recommended designs, the results, the KE agent strategies of integrating a network and LLM is more accurate than relying solely on the LLM for that. And in the text-image comparison, to integrate how the image generation models responses a keyword in text prompts, we analyze the differences of clip relevances between the keyword and various patches of generated images. And here is what we can do. Existing methods focus solely on the relevances between the keywords and local features. It is one page of the images, and it does not consider their impact within the whole designs. So we proposed a new method. It represents the response of the keyword to each page by calculating the differences in the relevances between the original image and the remaining part of the image outside the page. So the impact of the local designs within the whole designs can be considered. And here is our evaluation result. We can see that our method can gain more better precision and recall compared to the baselines. And we also conduct a user study to evaluate AutoSparks. And each of our participants was required to create an automobile appearance designs for a target consumers. 12 with 2 different systems. One is AutoSpark and one is baseline systems. And here is our result. We can see that our method can gain more better emotional expression and aesthetic qualities and novelties, and also can help the designers to get a broader exploration of the design spaces. Okay, and here is some findings about our user studies. And the most interesting one is that even though the underlying models are the same, but AutoSpark obtained a more innovative results. And the baseline system tend to repeat the existing designs. And we think that it may be caused that in the baseline systems, many prompts is crafted by the participants, and they also contain some emotional and stylistic keywords, and without detailed descriptions, and the model tends to generate traditional designs very close to the standard answers. And there are also some limitations about our works. So that's all, and thank you for listening.
I invite everybody to ask questions about this paper now at the posters. So thanks everybody for attending the session. Congratulations again to the authors. Congratulations again for the Best Paper Award. Make sure to check out the session and now use the remaining 5 to 8 minutes to speak to the authors. Thank you so much.